Alright, now I'm going to start on our last unit, and I'm going to start with the 9A notes. The first thing we're going to start talking about are functions. And a function is a rule that assigns each member of some set of x values exactly one member of another set of y values. And that seems kind of strange, but it is very important that each x value only goes to one y value. And I'll draw a graph as to show you what's going on here. And these will be little strange looking graphs here. If I look at this first one, it's a function because 4 only goes to one y value. Remember, domain is x, range is y. So my x4 only goes to 12. My 14 only goes to 6, and my 18 only goes to 12. So if I draw a little mini graph, my x's are on the bottom, 4, 14, 18. My y's are 6 and 12. And if I plot my points, there's 4, 12, 14, 6, then 18, 12. There's nothing literally on top of each other. If I have a vertical line that goes through both of them, if you remember from Unit 5, vertical lines have undefined slope, and we cannot have undefined slope. And we're going to learn about the vertical line test in about a page or two of this notes. If I look at this graph here, if I draw this one here, you can see this will not be a function. My x values, again, are right here. My y values are here. 4, 5, 6, 7. So if I plot now, negative numbers wasn't the brightest idea here. We're going to start. This is going to be a weird looking graph here. Negative 3, negative 1, 0, 1, 3. If I plot 4, negative 3, 4, negative 1, 4, 0. Then I have 5, 1, 6, 3, and 7, 3. Now, all of these lines right here are good. If I look at this point, and this point, nothing's vertical. But if I look right here, I can draw a vertical line and hit multiple points here. If I can draw a vertical line through multiple points, this is not a function. Okay, this is a function. And if I look at the domain of the Washington area, let's make that the x value. If I draw here, my x value is Washington. Then I got caps, whiz, and gnats. And if I plot them, you can see it again forms a vertical line. But you can see Washington goes to the caps, wizards. Again, the x value is going to multiple y values, so this is not a function. Now, if it's not a function, what they call it is just a relationship. A relationship assigns each members of one set to another set. But we are mostly going to be looking at functions when they are truly a function of time. And the best way I can explain this with undefined slope is we go to a monthly earnings sheet. I'll draw it underneath here. If I have January, February, March, April, we'll do it in millions. We're big sellers. 1 million, 2 million, 3 million. In January, if I have a $2 million sales bit, February I only have 1.5 mil. March I have this. April I got 3. Now if I come up with a number where February actually had 3 million, and now I have two things here. That makes no sense because February can only have one total. If February has two different totals, that's impossible. There can only be one total, so this is why this would make it not a function, and this is undefined slope. Remember, vertical lines are undefined slope. Don't want undefined slope. All right, just quick again, the domain is the set of all x coordinates, or if you're looking at the graph, it's how far left or right it goes on. The range is a set of y coordinates, it's how far up or down it goes. And for plotting points, as I kind of was just doing, if f of 3 is equal to 7, the corresponding order is 3 of 7, or 3, 7. Remember, we usually write it in f of x form. So if I put f of 3, that means x equals 3. I put it in the function and I get 7, that means my y value is 7. Alrighty. Two quick graphs. F of x, again, is just a fancy way of writing y. This is in function notation. So if y equals 3, I have to go to where y equals 3, then I draw a horizontal line. Now that is a function because there's no undefined slope here. This next graph, divide each side by -3, I get x equals -2. So I go to where x equals -2, and then I draw a vertical line. I have undefined slope, it's vertical line. This is not a function. I know it did not ask that, but anytime we have vertical lines, no function. Now here we're just going to do some simple evaluations. F of x is equal to the absolute value of 3 plus x. Well, x is -4, so 3 plus -4 is -1. Now, any absolute value of anything is just how far it is from 0. Well, -1 is one space away. So if I put in 4, 3 plus 4, I get the absolute value of 7. 7 is 7 spaces away from 0, so that answer is 7. And so this next one, we just have a little function formula here. We're trying to determine Janelle's weight in pounds T weeks after the start of a diet. So find Janelle's weight 12 weeks after the start of the diet. So T is in weeks, so I'm just going to do 170 minus 2 times 12. If I put that in the old calculator, I get 146 pounds. Now, if I'm looking to find out when Janelle will weigh 156, that means I have to put in for the W of T. So it's 156 equals 170 minus 2T, because I got to find the time. I subtract 170 from each side. I get -14 equals -2T. Divide by -2. And I get 7 equals T, so this is 7 weeks. So after 7 weeks, she will weigh 156 pounds. Now we're going to do a vertical line test. If I can draw a vertical line and it hits the graph twice, it is not a function. So right away I can see right here, if I draw a vertical line right here, it crosses the graph twice, so this is not a function. And I could actually draw that vertical line here too, so I could draw it in 2 different spots. This next question, or where that KS came from, but if I draw vertical lines anywhere on this graph, I can never hit the graph twice. So this is a function. Vertical line test is a very simple way to do it. The domain. We have done the domain in units 7 and 8. The 2 most important domains are under the square root has to be positive, and the bottom of a fraction, like this is 1 over a denominator, the denominator cannot equal 0. So, if I'm looking for the domain of this, do I have either issue here? I have no square root to worry about. I've got no denominator. So this is all real numbers. I can put any x value in there and never have any problems whatsoever. My next one, there is a fraction now, so I gotta let the fraction equals, just the denominator equal to 0 like we did in unit 7. So 3x minus 2 cannot equal 0, plus 2 plus 2. 3 cannot equal 2 divided by 3, so x cannot equal 2/3. Or if they ask when is this function undefined, you would just say x equals 2/3. Just depends on how they ask it. The next question, I'm going to actually make a couple questions out of this, but the first one is, for the graph of the function f, determine f of 1. And we did this in unit 5 already. Basically what this is telling me is x is equal to 1. Well, x equals 1 right there. So now I got to find the y point on this. So if I go straight down here, then I go over here, when x is 1, y is -3. So my first answer is -3 here. Now the domain, if you remember earlier, how far left to right it goes. If I look here, it goes the farthest left is -2, the farthest right is 5. Now those are filled in dots, so that means my domain is in parentheses, brackets, -2 to +5. If I had open circles on that, then they would be parentheses. And so now if I were to write in an interval notation, that would be -2 is less than or equal to x is less than or equal to 5. Now if these were parentheses, it'd be -2 less than x less than 5. That'd be -2 comma 5 parentheses, if that's the domain. Now the range, well, sorry, I skipped a step here. All x values such that f of x is equal to 2. So what that means, we're really letting y equal 2. So I'm going to do this in green. If y is equal to 2, I see the only point here is right there. If I go straight down, that's -1. So I get -1. Now remember, the range is how high, I'm sorry, I said that backwards. It's how low to how high. Always want to go from low to high. And if you notice when I said how far left to right, the left are the low numbers, the right are the higher numbers. So now the lowest number on this graph is down here, -3. The highest number is 2. So my graph is -3 to +2, and we have that in brackets. Now, I'm going to change color again. Let's try to make this one red here. I'm going to plot some points up here. And they're going to give you some graphs that aren't continuous without lines. They're just going to plot some points. So if I were to ask for the domain of this, that's how far left or right it is, they're going to ask you to just list all the points that are in there. So if I were to look at here, it's going from 1, 2, 3, 4, 5. That's the domain. And they'll say use a comma to separate your answer. The range is how high or how low it goes. Now the lowest number is 4, the highest number is 6. So this would be 4, 5, and 6. Okay. And they'll have a couple different ones, and then they'll have some real numbers, etc. Let's see, let's try another color here. Oh, let's try to do this crazy effect here. I've never tried this before. Well, that's not too exciting. If I were to connect the dots there, the domain for this is how far left or right? Well, it goes infinitely to the left and infinitely to the right. So the domain would be all real numbers. Right now it's changing colors. So the range for this thing, that's how high and how low it is. Its lowest value is right here, and then it goes up to infinity, doesn't it? So the range would be x is greater than or equal to +4. All right. And you'll see most of these questions are multiple choice where you fill it in, so that will be very helpful to these questions. And that's it for Unit 9A. 9A is not too bad. It's a short section. 9B is longer, but then again, we end up 9C is nice and short again. Alrighty.